Hi, my name is Dominique Tate,
And my name is David Williams.
and our senior project was on creating an ideal workstation based on 5S and ergonomic principles.
So just going to give you a brief overview of what this presentation entails. We're going to go through an introduction, problem statement, some of our deliverables, our literature review, the methodology we used, our results, and then finally our conclusion.
For our senior project, we paired with Zodiac Aerospace at their Santa Maria location where they manufacture seat shells, mostly for business and first class seats. They are highly invested in continuous improvement. If you walk through their facility, you'll see a lot of implementation of lean and industrial engineering principles being applied, but there's a lack of continuity between how they're being applied. For our project, our area of interest was the armrest subassembly workstation, and as you can see to the right, there's an image of the current state. The purpose of our project is to create a workstation so that not only the people at this workstation, but all of the employees can learn 5S and ergonomic principles and apply it throughout the whole facility.
So just to go off of what Dominique said, our problem statement is to create a workstation that follows 5S and ergonomic principles that can be used as a training tool for the employees so that they can utilize a workstation properly. As you can see below is the current workstation at Zodiac Aerospace, and then our objective was to create an ideal design. So some of our deliverables include a literature review, alternative workstation designs, then a final workstation design, and then to create visual aids for training.
The first aspect of our literature review was to understand the 5S methodology, which aims to minimize waste, enhance organization, and ultimately increase performance. The 5 S's are sort, straighten, shine, standardize, and sustain. For our project, we focused on the first three, which ultimately increase organization.
So the next aspect of our literature review was ergonomics. Ergonomics is essentially redesigning and arranging things so that they interact with people more efficiently. The last aspect of our literature review was our industrial workstation design. And what we did was combine 5S principles and ergonomic principles to create a workstation that is user-friendly for the worker.
Here's the methodology we used throughout our project. The first step was creating alternative designs. We then compared them in a trade study. We then went through a justification process, and then we selected our final result.
So here's the design approach that we used to create our workstation, and it's accredited by the two authors as you see there. This 10-step approach we used to create an optimal workstation that follows ergonomic and 5S principles. After our approach, we created multiple designs and then compared them with a trade study. As you can see below, the multi-criteria chart is based on a 5-point scale. The criteria below is essentially based on 5S principles, ergonomic principles, and the client wants. After comparing our alternative designs and analyzing our multi-criteria chart, here are the results. Okay, now we're going to justify the proposed layout for the design based on our design principles. So one of the design principles we used was to gather anthropometrics, and we used this data in creating our workstation. We also took into consideration workstation height. We made it so that the workstation could be adjustable. The workstation height is adjustable to better fit the heights from different users. Not only is the workstation height adjustable, but we also added in an adjustable chair as well as ergomats. These ergomats make it easier for workers who are standing for a long period of time, as well as having the option of sitting in a chair. So one worker will be sitting down and one worker will be standing up, and they will be able to rotate.
Another feature that we added were drawers and bins, which were placed within normal reach of the workers. We allocated the drawers and bins for the parts and products that they use regularly. Another aspect of our design principles was having frequently used tools close to the user. So though we allocated space for the tools within the drawers, while the users are working with them, it is better based on ergonomics and 5S to have a place for them on the work surface. The last design principle that we're going to highlight in this video is the displays in line of sight. We decided to have displays going across the workstations so that there is enough room to place all documentation that is necessary for work. The current workstation does not allow enough space for all the documentation and instructions, and workers have to turn and bend to get them from other places. Having the displays right in their line of sight is very important and reduces a lot of strain on the body. We also wanted to analyze the economic impact of our project. Let me start off by saying the monetary details were not shared, so we addressed each consideration as a form of profit or loss. The first consideration that we had was the type of material used for the workstation. They currently have two options, a cylindrical and a rectangular option for the metal to hold up the workstation. The rectangular offers a higher weight capacity, but it is not necessary for our workstation design. It is also more expensive, so it is a better choice to go with the eco-shape option. The second consideration is labor costs to build and place our station in the facility. The third consideration was the cost to actually do the training demos. This will be a cost that would cut into the production time or some other allocated time that they already have. The fourth point is increased efficiency, and this is obviously a cost benefit for them. The fifth is the decrease in injury, which is also a benefit, but one that they would likely see over the long term versus the immediate.
Continuing with our economic analysis, we researched a couple case studies to find out some statistics on implementing ergonomic workstations. So as you can see below, when implementing ergonomic friendly workstations, you can reduce injuries up to 10%, increase performance up to 25%, decrease musculoskeletal disorder up to 80%, and even have cost savings from worker compensation up to 40%, all of which is obtainable in 1 year. You can also see the quantifiable costs with repetitive strain injury. So in conclusion, in theory, reducing movement, organizing the workstation design results in a better work performance and a safer environment.
One of the things that we learned during this project is that implementing improved systems requires a lot of current investment, and sometimes results aren't seen until the far future. Our senior project got us to the design phase of creating a CAD model. But the next steps of our project would be to actually build a prototype, design the training demos, do the training demos, and rate their effectiveness in the facility. Our senior project doesn't have a high environmental impact besides the use of recycled materials in the facility. But the social impact is significant. It will reduce strain on the workers, and it would also increase productivity.
We look forward to hearing your questions, and thank you very much for watching our video.